What is going on today? I hope that you're having an amazing, blessed day. My name is Nasser, back at you again with a brand new math video. And in this video, I'm going to show you how to differentiate implicitly. Before we understand what implicit differentiation is, we have to understand what is explicit differentiation. Well, explicit differentiation is what we have been doing so far, which is taking the derivative of a function that is written as y equals. So explicit, y is alone on one side, and all the other x's are on the other. I've got a question for you. Is this an explicit function? Is this here an explicit function? Is y solved for itself and then x is on the other side? No. As a matter of fact, you can see y's mixed in with x's. And this is called implicit form. This is called implicit. So this is called implicit form. Implicit means yes, there is y's, or yes, there's a y there, and you're going to say that y is a function of x, but it's not written as y equals. So y is still a function of x. It's just bounded up in the problem. That is what implicit means. Okay. However, I can take this function, or I can write this function explicitly as well. I can write it as y equals. So I can take y as a common factor equals x, and then divide y equals x all over 1 plus x. So sometimes I can change from implicit to explicit. Okay. So now you might say, okay, I could just turn any function into an explicit form and take the derivative and solve it. Well, consider this example. Now, would you say this is implicit or explicit? And of course, you would say this is implicit. It is not written as y equals. Okay, could you solve it for y? Could you solve it for y in such that it's y by itself equals a function completely in x with no other x's? Of course, the answer is no. It's impossible. This cannot be written explicitly. So sometimes there is no way. Okay, here's the deal. Going back to the first example. If this is implicit and I can solve it explicitly, in fact, that will involve the quotient rule. This one, though, there's actually no way that we are going to be able to get that as y equals something in terms of x. What that means is that even if we get y by itself, there's still going to be other y's on the other side. They're of course going to mess you up, and we don't want that. So imagine if I get this other y, the other side, with a different sign, and then take y as a common factor and then divide, there are still going to be other y's on the other side. Okay, so we have to have another method to find derivatives instead of just having y equals a function of x. There got to be a different way, and there is, and it is called, and of course there is, and it is called implicit differentiation. That is what we are doing today. That's kind of an interesting question, right? Can you take a derivative without having it as y equals? Yeah, you can. And we're going to look at that today. All right, now let's get on with our first example. I got x cubed plus y cubed equals 5. Okay. So would you say this is implicit or explicit? This is implicit, of course. Y is not alone. y is mixed up with x's, okay? So how to differentiate implicitly? Well, I've got a few steps for you. Step number one, derive both sides with respect to x. Well, you know how you can add something to both sides when you have any equation. You can add something to both sides, subtract something from both sides, multiply something from both sides, or the same thing goes for the derivatives. You can take the derivative of both sides. So d dx, of course, is with respect to x, plus y cubed equals d dx to both sides, remember? Okay, now I'm going to take the derivative. Okay, usually I wouldn't do this, but this just to make it clear. Derivative of x cubed plus the derivative of y cubed. Of course, this is all with respect to x. And what is the derivative of 5? 0. This is the easy part. Okay, now take the derivative of x cubed. Multiply, subtract. Multiply, subtract 1 from 3. That's 2. Plus, take the derivative of y cubed. Multiply, subtract. Multiply, subtract 3. Subtract 1 from 3. That gives you 2. Okay, now, I want you to bear with me now. I want you to focus. If you get this next step, you will know how to differentiate anything implicitly. Okay, now, let's look at this note right here. It says, each time you derive y, you must get dy dx on account of the chain rule. Well, what does that mean? Well, if I tell you 3x plus 1, or let's just say 3x to the second power plus 1, all quantity cubed, okay? And I tell you take the derivative of that. We're going to use the chain rule, general power rule, multiply, subtract, multiply 3, 3x plus 1, multiply 1, take 1 from 3. Are we done here? No, we're going to take the derivative of the inside. That is exactly what the chain rule says. Take the derivative of the inside, dx, inside, 3x squared plus 1. That, of course, would give you 6x, right? Well, the same thing goes for taking the derivative of y. Well, let's take this here. This is y cubed, okay? This is y cubed. Well, this is the same as saying y to the third power. This is the same thing, right? Now we're going to say, take the derivative. So multiply, subtract. Multiply 3, subtract 1 from that. Okay. Now, what is the derivative of the inside? Well, the inside is y. So take the derivative of the inside. So d dx of the inside, which is y. Okay. Now, what does this say? This says the derivative of y with respect to x, right? Well, what does this say? This is the same thing, right? This says the derivative of y with respect to x. And that is why every time we take the derivative of y, we say dy dx. Well, some might say, okay, why don't you do the same with x? Well, let's do the same with x. Let's try it. That's x cubed, okay? This is the same as saying x to the third power, right? Now, do the same thing. Multiply, subtract. 3x to the second power. Now, we're going to say that take the derivative of the inside, same as the chain rule. Dx, dx, or let's just say d dx multiplied by the derivative of the inside. And what does this say? This says the derivative of x with respect to x, okay? So dx, dx, this is the same as this. So what is dx, dx? Dx, dx is 1. So 3x squared. So this is why we don't write, or we don't do this, okay? Because this is just the same. So because dx, dx is equal to 1. So we don't write it, okay? So if you get that, you can differentiate anything implicitly. So from now on, I'm just every time I take the derivative of y, I'm just going to say dy dx. So I took the derivative of y, I'm going to say dy dx equals to 5. Now, the second step, solve for y for dy dx. The calculus is done. Now it's just the algebra. You just need to solve for dy dx, and that's it. So let's just solve for dy dx. dy dx. Move this to the other side, change its sign. Negative 3x squared. And now we're going to divide by 3y squared for both sides. So divide, that will give me 1 on this side. And then divide in here, 3y squared. And of course, we can do this. That will give me x squared over y squared, which is dy. And that is it. That is your answer right here. Okay, now this is the second example. Now, could you take the derivative of that? You know what? Why don't you practice that right now? Pause the video, go ahead and find the derivative. Find dy dx. You got this. Okay, hopefully you've paused the video. Now we're gonna do it together. Okay, same steps. Derive both sides with respect to x. Okay, let's derive both sides with respect to x. Okay, why is it red? Let's take the blue color, d dx, the color of the skies. 3x squared minus y squared equals to, remember, do it for both sides. 16. Derivative of 16. Okay. Now let's take the derivative of 3x squared. Multiply, subtract. 3x, subtract 1 from 2. That gives you 1. Minus, multiply, subtract. And remember, each time I take the derivative of y, I get dy dx on account of the chain rule. Okay, so let's just write dy dx. This is the easy part. What is the derivative of 16? 0. Okay, now we're gonna solve for dy dx. Gonna move 6x to the other side by subtracting 6x for both sides. That gives me negative 6x. I'm going to divide negative 2y from both sides. So let's just divide it from both sides. That gives me negative 6x over negative 2y, which equals to 3x over y. Now, did you get positive 3x over y? If you did, that's great. Now, unfortunately, this is not the question I'm asking for. The question I'm asking for is find what does that mean? This means this is the second derivative. So find the second derivative. And this is easy. The second derivative just says, hey, check this out. This is kind of cool. Why don't you just take the derivative of both sides? So the same thing. Let's take the derivative of both sides, of course, with respect to x. So d dx, dy dx, d dx, x over, okay, 3x over y. Okay, this equals the second derivative. Okay, now this right here is the quotient rule. You can see the quotient rule right here, the little rainbow, remember? So I'll say the bottom squared, and then up top, we're going to say the bottom times the derivative of the top minus the top times the derivative of the bottom. So let's do that. So let's write the bottom, which is y, multiplied by the derivative of the top, which is 3 Sorry for that. Minus the top, which is 3x, times the derivative of the bottom. Now, what is the derivative of y? 1. dy dx. Okay. All right. Let's continue. Second derivative. All right. Squared. This gives me 3y minus 3x dy dx. Okay. Now, this is kind of weird. We've got dy dx here. Okay, what is that? This is it. So we're just gonna plug it in. Okay. So we're just gonna plug it in. So always watch out for that. Okay. So we're just gonna plug it in. Dx equals 3y minus 3x, and then plug that in. 3x over y. All over y squared. Now, just to make it easier for us, we're going to multiply by y, top and bottom. Okay, that equals to 1, so it doesn't change. Just to make it easier for us. Okay. All right, now multiply y, distribute that y, and distribute that in here, and distribute that in here. And of course, the bottom. Don't forget the bottom. Okay, that gives me 3y squared minus 3x times 3x. Because if we do this, it's gonna happen, cancel out. Okay, y times y squared, that gives me y cubed. And of course, 3x times 3x, that gives me 9x squared. Okay. Now check this out. This is kind of cool, at least for me. What if we take -3 as a common factor? Okay. What if we take -3 as a common factor? What will happen? Let's try it. Let's try it. -3. Now this gives me 3x squared and then negative y squared all over y cubed. Okay, now where do I see this? This looks familiar. This right here, this looks familiar, doesn't it? I mean, I've seen it somewhere. I feel it. I feel that I've seen it somewhere. Where did I see it? I saw it all the way up there. Ha! Isn't that cool? Okay. So 3x squared minus y squared is equal to 16. So we're just gonna substitute that. Just gonna put 16 in here. So what is 16 times -3? Well, that gives me -48 all over, or no, -48 all over y cubed. And that is the answer. Yay. Okay, that is it for me today. I hope that you enjoyed this video. My name is Nasser. Have a great rest of your day and peace out.